Hello, how are we all? Hi, my name's Clifton. I'm one of the iOS developers with Bound. And today's topic, what we will be discussing today is Kotlin Multiplatform and adventures in KMM, which kind of feels weird because this is a Swift talk, but we're going to be talking about Kotlin. But we'll dive more into that as we go on. As we get started, I want to introduce Gerald. He's one of our lead iOS engineers at Bound. I've introduced myself as one of the normal iOS engineers at Bound. And then we've also got Vlado, who's one of the partner and co-founders of Bound. And I guess you guys are all familiar with both. All right. So yeah, just a bit of an agenda of what we'll be going through today. So you can see we got talks on multi-platform, what is KMM, a bit about the project background, and a little bit about the clients that we've worked with that use KMM. And then we're going to have Gerald deep diving into the code and showing you the more under the hood style of how it all works. So yeah, let's get it started. So yeah, an all too familiar thought is, wouldn't it be nice to be able to write code I could use both in iOS and Android? And as I'm saying this, you guys are probably already thinking about multiple different tools that you can use that can do it. And as you can see, for example, you've got your Flutters, your React Natives, you've got your Xamarin, and some of the ones before my time are up there as well. So if I can get a show of hands, who has used these kind of tools before? Yep. So a few of us here are familiar with it and whatnot. So yeah, I guess when we go, into terms of planning an app or how we're going to build an app, we kind of have these kind of questions within team members. We got our designer being like, we still want to be able to create the best possible UI, the buttery smooth native animations and microtrans interactions. We also want a language that's also very familiar to the mobile team, so we're not having to learn, for example, like Flutter, which is going to be a whole nother paradigm, or React Native, which is the JavaScript side of thing. We want to be able to share logic between the apps that's going to help us with consistency and functionality. And this is where Kotlin enters the room, or Kotlin Multiplatform. Before I jump a bit more into this, if I can get a show of hands, has anyone here used Kotlin Multiplatform before? Awesome, we've got 1, 2. Perfect, no, that's good to hear. 3. So yeah, one of the good things, it's a new tool for sharing code between platforms, and it's written in Kotlin. So if your team is split in half with Android and iOS, it's great because you're not having to learn a third language in terms of your code base. And also the benefits of Kotlin multi-platforms are the views are all still written natively. So you're still writing iOS code from Swift and you're still writing Kotlin or Jetpack Composer, depending from how you go it that way. What you're really wanting to do with Kotlin multi-platform is you're wanting to share the business core logic. So like your data models, your API calls, you want to handle that all through the KMM side of things. Very flexible, you can set it up in the same repo. You can also set it up through your CI pipelines. It outputs through CocoaPods, and you can use their Swift package manager, but you're better off using it through the XC framework. So one of the clients that we're currently working with is BTC Markets. So we came in and we started working on the app and using different types of tools and how we can go with that. So one of the first thing is we early adopted it was with Swift UI, decided to go down that path, and also use the adoption of KMM because it was starting out and we could still launch the app fully native. One thing I do want to show you here in this diagram here is probably the best way we found using KMM is the two things down the bottom, which is business logic. So use cases, interactions, utility functions, and also the data layer things. Like I was saying before, you wouldn't be using this like some of the other ones like Flutter or React Native to do the UI logic. That's still handled natively. It's essentially you're handling, like I said, yeah, the business logic and the data layer. You can put it into things like view models and presenters, but we found that just caused more of a hindrance than anything, so you're better off just sharing the data. All right, after I've given you sort of that overview, I'm going to hand you over to Gerald, who's going to go a bit more of a deep dive into it.
Cool. Thanks, Clifton. So yeah, Clifton went over kind of generally what kinds of logic generally go into KMM versus not. So specific use cases, what would we do? So these are just kind of a list of some of the ones that we used in BTC. I'll just talk to a few points of these. So for example, networking. You'll see in the infographic on the side that we have, it was a survey of developers that were using KMM, like what were you using KMM actually for? And like number one, networking, because that's, you don't really have much platform specific code. That's pretty safe code to use, to share. And then like in the bottom of the list, 50%, the least amount is the view models and the presenters and the controllers. So that's where you kind of get more into iOS specific or Android specific code. So they're still a little bit shaky on that. So you can see in the list here, none of these are like view model-y types of things. There's a few like analytics, and that's where we did touch it a little bit. I'll talk more about that later. But yeah, API authentication, serialization, that's all network calls. Another one that we found was really useful was feature toggles. So we had an API that passed down feature toggles, and that API was just handled by KMM. So that read the API, and then it just gave like the booleans over to each of the clients, and then they're able to feature toggle off of that. Dynamux is a really good one as well. So instead of having to write boring code to mock out all your data for your tests and Swift UI previews, you can just write it once in KMM and just use it between both platforms. So getting into how does KMM actually work? So it's written in Kotlin. You have Kotlin libraries to be able to do like foundational type of things, and then you can add on third-party frameworks to do things like network calls. So like Kotlin has a library called Ktor, which is a lot of most Android engineers hopefully are familiar with, and you can use that to do network calls. Now, if you actually want to get into like platform-specific implementation, so like you can see on the picture that we have, we're trying to generate a UUID. So this one, KMM itself doesn't support, or it might later, but for now, you can have an iOS-specific version because KMM actually includes Foundation under the hood, which is the Objective-C flavor, not the Swift flavor. But you can use Foundation APIs to be able to do things like generate UUIDs, date time, and access like user defaults and things. So those are some good examples. And so you just define expect, which is kind of like a protocol, and then you have implementations in each of your clients, so iOS and Android. So the one kind of bad thing about this is that you are, once again, writing the code twice, but just within the KMM module itself. So you will have to, like you are writing the code again twice, and you'll probably have to write tests for it again. So that is one thing, but you are keeping it within the KMM module, which is kind of nice. Yeah, and then you also can like define, they call it interfaces in Kotlin, but we know as protocols. You can define like an interface in KMM and then inject in your own implementation from the client side. So we did this in, like, for example, Firebase. There is no Firebase KMM kind of thing. So we defined it in each of our clients, and then we injected Firebase into like our analytics manager in KMM. Also, just a nice little bonus as well is recently Kotlin coroutines was, I guess, supported in KMM. So now you can use async await as well, and it handles it natively. So what are benefits that we've seen in the project? So definitely, like, we've gotten higher velocity because, of course, we're sharing code. We're not having to write things twice. And part of that comes from simplified testing. So, for example, our network calls, like, we only have to test once in KMM, and then we can be, we know that it's good because it's been tested in the KMM side. We don't have to do it again in the iOS and Android side. And guaranteed consistency. This is things like, say, analytics keys. If someone makes a spelling mistake, like on the Android project and on the iOS project, they get it right. Like, you don't have those errors anymore because it's all in one place. And so those kinds of things are nice to have just in the one code base. That kind of goes with the last point, the lower bug occurrences, is if like something like an analytics key or network call, there's an error in that, you kind of know who to blame. It's like, oh, those KMM guys. And so, like, yeah, it just frees up some time for developers to focus on UI. And it's, I guess it'd be kind of the same benefits if you were splitting up, like say your network module into a team. You kind of have, it kind of forces separation of concerns in that way. So on the other side of the coin, so what are some challenges that we got with KMM? So KMM is still a work in progress. It only recently went from alpha to beta a few months ago. So like the platform itself is still, they're still working on it. And also third-party support as well. So there's still, you can't just take any old Kotlin Android library and just expect to use it in KMM. There's only a subset of Kotlin libraries which are designated like multi-platform or Kotlin/native that are usable in KMM. So a lot of like Android developers might, for networking calls, for example, a lot of Android developers might use, I think it's called retrofit. So they can't use retrofit, unfortunately, because it's not Kotlin Multiplatform compatible. They have to use Ktor. Of course, like us working in Swift, if we want to do stuff in KMM, we have to learn Kotlin, and it's not too bad, I promise. So it does look kind of similar, and I can show you some demo code later. But yeah, that's just something to be aware of. The language syntax itself, for me as like a Swift developer, that one wasn't too bad. But what was a little bit more of a hurdle was the architecture differences. So like Kotlin developers, they like to do things in a certain way that kind of grates to the way that we've kind of been used to doing things in Swift. And trying to bridge between those two architectures was actually more of a hurdle than the syntax differences. Luckily, the Kotlin, they have a nice documentation on kind of, we have this paradigm in Kotlin versus this paradigm in Swift. Like, for example, like they call it interface in Kotlin land. We call it protocol in Swift. So that this is like a really good documentation to kind of look off and see like, oh, I'm used to calling it this, what's it called in Kotlin land? So that was cool. The other thing to watch out for is the initial setup of KMM can take a little bit of time. Just setting up a new project, I mean, they have wizards and things, but you still have to like integrate it properly. Depending on how you want to set up your project, like if you want to have your KMM module in a different repo than your iOS project, you're going to have to set up CI pipelines to be able to like take the XC framework and link it to your iOS project. So that's setup time. Debugging is a little bit of an issue. So that's really where highly would suggest testing your KMM module so that you do less of the blame game on that you can kind of depend on your tests to tell you like, oh, then something's gone wrong in the KMM module. The other thing that tests are really good for is if like a third-party library or KMM itself does a version update and it breaks stuff, your test can kind of tell you what's gone wrong, hopefully. Right, and then also just trying to architect things in KMM to be mockable in your clients. So like, for example, network calls, you want to be able to mock out your network calls, and you kind of have to think about architecting in KMM so that you can do that in your clients easily. Cool. So the big question, how do I know if it's right for my app? So like we've gone through, KMM isn't really a magic bullet where like some of the other multi-platform frameworks kind of promised. It's just really another tool, and sometimes the tool is right for the job and sometimes it isn't. So if you have a project where you already have a lot of business logic sharing, you have a really good BFF where all your business logic is kind of consolidated, and your clients are really just dumb clients that's reading from a really nice API, then KMM might not give you as much benefits. One other thing that's kind of cool is if you have an existing Android Kotlin project, you can kind of carve out the KMM from it. That's kind of the transition that we went through at BTC is that they were able to just kind of take the networking code, and then pull it out into a KMM module, and then we were able to use it in that way. Again, like, you can't use retrofit, you have to convert it over to Ktor, but I think it didn't take that long for them to do the conversion, so that one went quite nicely. And then for your team makeup, would recommend at least a senior level Kotlin engineer who knows how to like architect the app properly, knows how to use Android Studio well, and then because you're going to be doing more of your coding in Kotlin, you want to either have enough like Kotlin engineers or have iOS engineers willing to mess with Kotlin here and there to support that. Cool. So I have a demo up on GitHub, and this is a public repo as well, so there's a QR code if you wanted to scan that. So this is a really simple app in that it's just pulling from the GitHub public repository of all the repos that Melbourne CocoaHeads has. So you can see it's just pulling from the API, and it has like an avatar image, a title, the date created, how many watchers, and the forks. And then we have these little hearts on this side. So this is it isn't actually like, what is it, favoriting or hearting the repository. This is just local. So this is kind of trying to demonstrate like we're saving it to local storage. So when I stop and start the app again, that it'll, yeah, so it's persisted. So the app itself is, you can see that we still have like views. So we have like a content views. We have our view models. This is a view model here. And we have a manager. No, that's the mock. Here we go, app manager. So we still have our view code.
Can you zoom in?
Oh.
Please. Thank you.
Cool. So this is, you can see from like the manager, the view models and the views, like that's all native Swift code. And it's only in this manager layer that we're kind of interfacing with the KMM library. So we can have we call it shared because I'm lazy. But that's importing the KMM, which is, it's being provided as an XC framework here that's linked to the project. And then here I'm just using use cases. So this favorite use case is coming from alt. It's coming from the shared Kotlin Multiplatform. So that's defined there. And then we're just using it. So we can see here that, like, say, load data. This is using async await from the KMM use case. And then we can extract data from that. So it's pretty easy to work with as long as like you do things on the other side pretty well. Yeah, and then I just had to do like a few converters. So one thing, this is where one of the architecture differences is like, normally with async await, you just want to return back the value. That was a bit hard, so we had to wrap it in like a result type. So I'm having to extract the result, the value from the result. So I just wrote some helpers and converters to help me do that. And I'll show you what's going on in the Kotlin side. So this is the Android Studio, and this is the KMM side of the code.
I have to zoom in.
Command inch.
Oh no, really?
Yeah, you can see I've been using Kotlin as well now. All the things for Android Studio.
I'm glad you know, because I'm just like, so this is the, yeah, so this is the basic like repo. No, and it's not persisting.
No.
Okay. All right, so that's like the repo model, and you can kind of see like this. You can think of this as like a struct, the data model. They just call it slightly different things, and we have the serialized info that's coming back from the GitHub API. So we have like ID, name, fork count, that kind of thing. What we've chosen to do in this the KMM side is do things like the accessibility string. So we have an accessibility string here, and we're constructing that there. So this is where we build it here, and we get it for both iOS and Android. in the use cases, yeah, so this is just calling the repository. And this is like the protocol for the repository that's doing the network calls. And then this is the actual implementation of it. And so you can see here, it's just grabbing it. So yeah, it's not too bad. So one thing I'll show off, this is an example of one of the expect classes. So this is, we're trying to save and pull things out of local storage. And we'll have implementations in iOS and an implementation in Android. And so this is kind of the expect of kind of like the protocol. And so in iOS, we can go to here. And this is the implementation. So you can see we're pulling from Foundation, and we're using familiar framework code, user defaults. Yeah, we can just do that. So this is the old Objective-C flavor of it, which is why we still need to call things like synchronize instead of the newer Swift one. Yeah, and so that's one example of expect actual. Another one that we did was having called shared logger. So this is where we're just doing an expect function on print native. So this is help print logs to the console for debugging purposes. So I think on Android and iOS, they have slightly different implementations of how to print to the console. So we have an expect here, and on iOS, we just do a print line. So yeah, so maybe just the working with, I just realized I didn't zoom in on any of that, sorry.
I was wondering where to jump in.
So I might do an example of just how to work with starting from the KMM code and working my way up. So let's say, oh, I need to actually discard all my changes. Okay, so we have this description field that the API engineers suddenly say we're not wanting to give you this. So luckily, in this code base, we're not actually using it in the UI, but we'll look at how to remove it and then fix it up the line. So if I move description here, I think it'll break on the mocks. So yep, we'll remove it from the mocks. Oh, come on. Cool. And what I'm doing is I'm just running the Gradle task to, it's really hard to read up there. It says assemble XC framework. So this will generate the XC framework for me. The way that I have the project set up, it's easy to work with because kind of like a mono repo, my iOS app sits in the same folder structure as my KMM app. So I can just build the framework, and the iOS project is linked to where that framework appears. Like normally in a production app, like if you had it in like a different repository, you'd probably want to be running your CI pipelines to move the framework over correctly. But yeah, locally developing, it's actually really easy. I just run it, it's generated. Can I zoom that? Yeah, it says execution finished. And then when I run the iOS app, it's failed because there's no more description anymore. So now I can just fix it at this point. So this is a converter that I've made. So this is kind of an architecture decision that I guess that I've made to try to limit the reach of KMM to, I didn't want it to touch my view model, so I made a converter, and I converted it into a cell model. So my view and view models only have to deal with this. So this is kind of nice so that it limits the damage when things change in KMM. And, well, okay, there we go. No, my Xcode is fail, pass, fail, pass. What's failing? Oh, right, because I didn't change the, yeah. There we go. Cool, there we go, works again. Cool, and so that's the end of the talk. There's our contact information if you feel like asking us about KMM. So all three of us have actually worked with it before, so
Yep.
yeah, feel free to ask any of us questions.
Different projects as well.
Yeah.
So we've used it more than once.
All right. Yep. Okay. I can see a few questions. While he's walking the mic, I have a question for you. So on the Xcode side of things, can you drill into the definition of stuff the same way you would with any other generated Xcode framework?
No. So it'll tell you the class name, because like when I did the alt click, it told me the name of it, but then I kind of have to switch over to Android Studio and then look for it in there.
Yeah, it drills into like a Objective-C kind of headers. Whoops.
Yeah.
Drills into Objective-C headers.
Right. Okay. So it's an Objective-C based XC framework.
Yeah.
Gotcha. That clarifies things.
I have two questions. One is because it transpiles down to the Objective-C or C, right? You kind of create this overhead of like, I think last time I measured about 1.5 megabytes per framework or per XC framework. How do you justify that cost? And then the second question is, why not C++?
We're trying to make life easier, not harder for everyone.
Well, C++, you get LODB, right? And you can drill down to it. There's a lot of good things in there. But yeah, sorry.
I guess like the cost of it, we haven't run into, I know in the project that I was working on, we didn't run into issues where we were like super concerned about the app size, and so it was better to have the cost savings from the resources, like in terms of less developers needed, and sharing the logic in that way we could move faster.
I think it's also the the dependencies we used from Android they were very common dependencies, like generally stuff like analytics packages. We still use the native stuff in Swift, and then we just kind of created protocols to wrap and inject that back into the KMM level, so you kind of don't get that trade-off a bit. I guess it's the explanation, yeah.
Oh, hey, also at the back here. Sorry for the back row asking all the questions. Comment first. You need to update your screenshots. Bitcoin's much higher value this week than it was. Second thing, I don't really have a question. It's more of a +1 to the KMM kind of model. In my recent experience, one way we handled the multi-platform kind of view model, like business logic, as you described in your diagram, was we actually shipped JavaScript files to each client and then rendered it literally on iOS, in a web view behind the scenes, got the output, then did something with it. That didn't scale very well when you have tens of engineers needing to make changes all the time. So what we did is we rewrote it in Kotlin, because you get the static analysis and you get all those kind of components of Kotlin instead of JavaScript. And we also had hundreds of Kotlin engineers that knew Kotlin. So what we did was re-platform our JavaScript into Kotlin Multiplatform and ship that to our clients, and it's just made the whole process much better. So if you've got shared logic already, I mean, we did it that way, but the Kotlin Multiplatform solved that problem going forward. It's a really good thing for sharing that business logic. So you're like a +1 for that model.
Yeah, and if I can add to that, I'm coming from the iOS side of things and working with the Kotlin side. Because you are just looking after business logic, you're not having to worry about the complexities of the UIs or how Android does certain things. You're just handling straight business logic. And after doing a few tickets in Kotlin, you learn to work with it pretty easily.
Speaking of the UI side, have you looked at Compose Multiplatform?
Well, we just saw it today, actually. At that point, I would almost be like, why don't you just use Flutter? But yeah,
Yeah, our debate was kind of like, wouldn't you just use Flutter? Because it seemed a lot more mature.
Well, so if you've already built out a shared business logic library using Kotlin, and maybe you already have an Android app already using Kotlin, then you only need to port the UI layer. If you wanted to use Compose multi-platform on both.
I think that one might be an interesting one to keep an eye on because we just noticed it just went into alpha for iOS like 4 days ago or something, right?
It's very new.
Yeah.
But theoretically, if you have an Android app, you could refactor it in a structure that would allow you to very easily, I'm sure, not easily, convert it into an iOS app.
Yeah, the only other thing I could think of is I think REA did a talk about shelling in their app and how they had web shells and native shells and all of that. Like if that, investigating that tool, is it possible? Could you do like a composable, shell where you could share some UI, maybe like a compartmentalized version between platforms? That would be an advantage, I think, on top, instead of using like a React shell or something like that.
Yeah. More a comment. One of the things that I've seen in, again, the joy of big corporate life, JVM is more often than not the stack for behind the scenes, and so building backends in Kotlin is a possibility, whereas something like building it in a Swift server isn't. And one of the things that we've implemented recently is our backend builds the libraries for the front end, so you can actually, with Kotlin called KMM, you can have your backend actually build the client library, so all of the classes for serializing and deserializing your JSON and things like that are actually guaranteed to work because the same code that's actually used to generate the JSON is actually used to ingest the JSON. And we've actually found that to be a fairly big win in terms of the only problem with it is if you have a guy on the server who makes a stupid spelling mistake, the client side has the same stupid spelling mistake, but everyone has the same stupid spelling mistake. But it reduces the number of errors along the way and the amount of just, no one likes writing out a JSON format into a class library. It's just another thing that gets rid of boilerplate in your coding.
Howdy, hey, thanks for sharing. So I noticed you guys were using like stuff like coroutines, async await. What about reactive programming frameworks like RX Swift, RX Java stuff?
I think like if you already have async await, like that can bridge over to what Kotlin. I noticed that the like those use cases, the methods I had available, I could either use the async await version or they had a completion block version. So you could use either one of those to bridge over to like RX Swift or combine.
Right. So at that point of the native platforms will have to bridge at that point, not before.
Yeah.
Okay.
But it would probably be like a good idea anyways to have some kind of like bridging layer anyways. So like if something changed on like the KMM side, it doesn't like blow up your views, for example.
All right. Thank you.
Cool. Thank you very much.